is Daniel Olshansky. I'm an intern here on the Android team at Google, and today I'll be talking about some folding animations. It's a folding animation kind of like an accordion, except you can specify the number of folds, the orientation, as well as the anchor point along which the fold is going to take place. So now while you'll be able to fold any image, as you'll see in the demo very soon, and the trick behind doing this is noting that given some number of folds, you can split an image into several different segments. Each of this segment is a rectangle that can then be transformed in various ways using matrix transformations. And then in order to make the fold even more realistic, what I'm going to do is use gradients along with shadow-like effects on alternating folds to actually get that real folding-like effect. In this demo, there's going to be, it's important to know that there's this fold factor that I'm going to be using that varies between 0 and 1. And what's going to happen when something has a fold factor of 0, it means that it's completely unfolded. Whereas when something has a fold factor of 1, it means that it's completely folded to the point where you cannot see it anymore. So that being said, let's jump in straight into the demo. So here we have just an image, and I'm going to start folding it. And as I'm moving my finger, you can see that the image gets folded and then it gets unfolded. This is 4 folds. You can change the anchor point of where it's happening, and once again the same thing applies here. I can change the number of folds to 8 if I want to. And the other thing you're noticing is this kind of sepia effect as I'm animating, and I can turn that off. It's a cool little feature I thought would add a lot to this, which I'll show you how to implement in a second. And the other thing about this is that you can even fold not just a static image, but also a live camera feed if you use something like a texture view. So here we have our camera crew, and folding and unfolding it. So it is a live image that is being folded and unfolded. Okay. So that being said, let's jump in straight into the code. And the way this works is folding layout extends a view group. So this is very generalized, except it's set up in such a way such that my layout can only ever have at most one child. But then again, this one child can be a layout that you can populate in any way that you want, and then fold even a user interface with buttons and text boxes if you'd like. So scrolling down, here I'm doing a lot of checks. So if you're trying to add more than one view, what's going to happen is that I'm actually going to throw an exception, because in this context, that's not something that's being supported. And once we get through that, then there's all the setters. So like I mentioned before, you can set the number of folds, you can set the orientation, and you can also set the number of folds, the orientation, and the anchor point along which it's being folded. So I also have not shown the orientation change yet, but the same thing applies when you're in a vertical as opposed to horizontal orientation. So then here you can set the fold factor, which is again a value between 0 and 1. And every single time you set the fold factor, you need to calculate matrices and invalidate. So invalidate will draw the folded view onto your canvas in its new folded state, and calculate matrices actually calculates all the transformation matrices that you need to go from the unfolded image to the folded one to some degree. For every single time some other parameter gets changed, we need to call this method called updateFold, which does all the preparation for actually folding a new image. So in updateFold, we're going to call prepareFold, and all prepareFold really does is return all our variables to default, because this is now a new image. It allocates space for all the transformation matrices we need, the paint objects, the gradient objects, and things like that. It sets up the gradient objects that we're going to need for later, stores all the values we're going to need, stores the original widths and heights of the images, and the most important thing that it does is right here where it splits the image into rectangles. So like I said before, in order to fold something, what you need to do is split it into separate segments so you know how each segment should be transformed. But every single segment is just a simple rectangle. So I'm going to store all these rectangles in an array, and I'm going to be referencing these rectangles as the source for every single transformation that I'll be doing. So that's the updateFold. Then in calculating matrices, this is where we actually calculate the transformation matrix. I'm not going to go through the math of how I did everything, but the main thing to note here is that you need to make sure that you reset your transformation matrix on every single time the fold factor gets changed. And the other thing to note is that the amount that a fold should be folded by is inversely proportional to the distance from which it is away from you. So, for example, when you start folding it, you'll see that the edges very quickly start going into the page, whereas when it's already really folded, the edges don't go into the page as much. A simple inverse relation achieves this, and that's how you get the fold. So back in calculating matrices, there's a listener that I added on end fold and on start fold. So what this gives you is just kind of a listener you can listen to when a fold ends or starts. And scrolling down past all the math, what we're doing here is we're going to be transforming a set of 8 points to another set of 8 points. Since every single segment is a rectangle, every single vertex has 2 points, an x and a y coordinate. So given the 8 points from the source and the 8 points in the destination, we'll be able to achieve the transformation that we need. So how we do that is using a function available in matrix, in Android's matrix API called poly to poly, set poly to poly. And what this does is take an array of source points, an array of destination points, and the number of points you're going to use. So in this case, that'll be 4, and this is limited to 4 at most. And so what all that's going to do is give us a matrix that transforms that original rectangle to this new rectangle. And in order to achieve the animation, the graphical effect here, the destination source has its edges kind of curved in, as opposed to just a rectangle, which is where all the sides are parallel and perpendicular to each other. And scrolling down farther more, the other thing we need to do is scale our gradient. So if you saw in the fold, every other fold has a very solid kind of overlaying black shadow over it, but then every fold in between that just has a small gradient going across it to achieve that more realistic effect. So the alpha value as well as the size and scale for all of these are all calculated here. Then in dispatch draw, there's a couple optimizations that we have. For example, if the fold factor is equal to 0 and it's completely unfolded, no folding needs to happen, so we just draw the original image and call super. In some other cases, like if it's equal to 1, then we don't want to draw anything. And then what we're going to do is loop through all of our folds and just start drawing each and every fold onto our canvas separately. So right here, first what we do is concatenate our canvas. First we need to save the state of our current canvas. Then we concatenate our canvas with the transformation matrix. We need to clip erect because all we really want to transform every single time is one segment at a time. So we clip that rectangle. We transit it appropriately so that it's located in the beginning of the view, because our transformation matrix, if you look at the map later, takes things from the very far left and then puts it in the correct position on the screen. We call super dispatch draw, and since the canvas is clipped, what this is going to do is only draw that clipped section of the canvas that we have specified. Then we transit our canvas back, and then using the same matrix information, we'll also draw the solid shadow as well as the gradient shadow on top of the folds that we've already drawn above. So one of the biggest problems that we actually encountered while working on this is that in Android 4.3, a new bug was introduced where if you call super.dispatch draw multiple times within one call to dispatch draw, it won't actually have the same effect as it does on 4.2 and prior to that. What's going to happen is all the canvas transformations are going to be delayed until the last canvas transformation, and only that last one will actually take effect. This is a bug which a patch will be uploaded for in the future, but in the meantime there's a small workaround that we found which only works for static images, not the live camera feed that you saw earlier. And the way this works is in prepare fold, what we're going to do at first is capture the actual bitmap that we can see. So we're just gonna take the child and capture that whole thing in a bitmap. The matrix transformations are gonna remain completely the same. But the only difference is gonna be is here. So if it is JBMR2, so Android 4.3, instead of calling super.dispatch draw and then translating canvas itself, all we're gonna do is take our bitmap, specify a source and a destination rectangle within our bitmap, and then use that transformation matrix to draw only that segment from that bitmap onto the screen where we want to. So it'll have the exact same effect on static images, but it will not have the same effect. It will not work for something like a texture view that continuously updates. The last thing that I would just want to show is how we add the sepia effect. So there's a lot of boilerplate code in this file to handle all the touch events, but here in unfold listener, which is a custom listener that we created, all we're going to be doing is adding a hardware layer on top of our view. And when you set a hardware layer, what you can also do is specify a paint object. So if it is a hardware layer, you can specify a paint object, and that paint object gets applied onto the view that has that layer. And if you look at Sepia Paint, it's a very simple color filter. They use a couple of color matrices with some values, and by overlaying that onto the view, you get the sepia effect as you're folding it, which can be very easily turned on and off by removing the layer off of our view. So that's how you do cool folding animation. Thanks for watching.